Okay, good morning everybody. Unfortunately we've had a few technical issues getting the stream started this morning, so I do apologise for the delay. The content is going to be recorded and is going to be available later on, so hopefully some of you that may have signed in this morning already missed the beginning because there's been an issue. You'll have a chance to rewatch this, and you're listening to me hopefully later on. So I'd like to welcome everybody. I'm the first up today. My name is Pip Corku, Head of Product, Technical and Digital Transformation at Abloy UK. And I think the fact that we're streaming these webinars live around the world is a testament to the digital transformation that everybody has had to undergo during the course of the last 12 months. Obviously, we'd love to be at a live physical exhibition presenting to you. But I think we'd all agree that at least the commute and the parking has been a lot easier for attending this morning. I'm going to be going through our RIBA approved CPD on digital transformation. We are using a new tool today for streaming these sessions, which is live over YouTube. Obviously there's been a few technical issues, but please do share this video content with your colleagues, and let's hope that we can beat our record attendance of our last virtual showcase, where we had over 1,000 visitors to the stand during the course of the day. We do also have new chat functionality on the stand, so if you're watching this presentation in full screen mode, if you remember to come out of full screen if you need to ask a question, on the right hand side of the YouTube window is the chat functionality. And we've got a whole team of Abloy experts on standby throughout the course of the day to address your questions and get information out to you. I won't be able to take questions during the presentation, but if you do have any questions, if some of the slides do spark some questions, then please do drop those into the chat, and as I say, one of my colleagues will be able to pick those up. So on with the presentation. We actually start our digital transformation CPD with a little video showing some of the digital transformation that we can see going on in the world around us. So hopefully this will stream quite nicely for you this morning. Okay, lots of interesting trends and statistics in that video. I think it's quite clear that with the speed of digitalisation, we probably need to update that video slightly for 2021. Certainly over the course of the last year, there's been a massive acceleration in adoption of digital tools for the way that we work. And of course, it's enabled us to do things like the virtual showcase that we're doing today. There are some important elements in that video. As much as there's some interesting facts in there, there are some important ones in terms of the considerations we had and we have as product managers and innovators at Assa Abloy in terms of developing some of the technologies that we're going to talk about in today's presentation. So we'll come back and we'll touch on some of the points that were raised in that video. Well, hopefully a nice, interesting introduction for you all to the world of digitalization this morning. So, on to new technology. So, new technology and innovation is about solving problems. There's no sense in developing solutions looking for a problem, i.e. solutions that don't really solve anything and therefore aren't really going to take off. So first of all, we need to find a challenge. There has to be a challenge that drives the need to develop new technology and to move in a new direction. And one of our challenges as legacy, as historically as manufacturers of key systems, and certainly from an Abloy perspective into professional end users and infrastructure supplying mechanical key systems, comes down to this concept of losing things. And we found an interesting article. It's a couple of years old now, but I couldn't believe it when we looked at this article. The average person loses more than 3,000 possessions in their lifetime. Now, some of these possessions are quite believable. I can understand it. But the first one, 64 umbrellas that people apparently will lose in their lifetime, which I think is quite shocking. I can't imagine owning 64 umbrellas in my lifetime. 192 items of clothing, slightly more believable, depending on what those items of clothing are, of course. 384 pens, I would say, is definitely likely. But the number one lost item, of course, is keys. Probably smartphones these days as well. And the reality is that a lost key can cause significant impact. It's not, if you think about losing your car keys and the personal inconvenience of that, or your house keys and the personal inconvenience of that, it's a major problem to your daily way of life. But when we think of organisations, certain organisations losing keys, it can be absolutely catastrophic, and it can certainly be incredibly expensive. And here's a few examples that we found. Didn't take long searching the internet to find some good examples of this. Opening weekend of the London 2012 Olympics, and the locks had to be changed at Wembley Stadium after the master keys went missing. There's also an example of a set of prison keys that went missing. Those keys were actually found, I think, 4 hours later. So they were only missing for a period of 4 hours. But not being able to account for those keys during that period of time is a massive problem to the Ministry of Justice. And the result is a £450,000 bill to rekey the prison. And then finally, the worst example, and thankfully, I guess for us, it's a little further away, £1 million bill as staff in North America lose the keys to a nuclear lab. And we can imagine what the potential fallout of that scenario would be. So our number one driver, despite all of the technology, the flexibility, the time schedules, the audit trails, the access profiles, all of the things that we can put into electronic systems when we think of security, actually the number one driver for our customers moving to electronic solutions in physical security is the fear of a lost key. And that's still just as true today, a decade on from selling the Click Remote solution, which we're talking about today, than it was when we first launched it into the marketplace. There are other drivers though, of course, and sometimes new technology is actually incredibly disruptive. So we can develop a new technology to solve a problem, but in solving that problem, we could create a whole host of problems somewhere else. And a very good example of this, particularly for us in the security industry, was already mentioned in the video that we started this morning's presentation off with, which is 3D printing technology. Now, this has a wealth of possibilities in terms of changing the way that we live our lives. It's absolutely a positive innovation in terms of what it can do. We saw examples of 3D printed engine parts for aeroplanes. We saw examples of surgeons practicing and operating on 3D printed body parts for improving and testing medical science. So these are obviously great big leaps forward in terms of technology. But that innovation can have some negative impact as well. And if we think of the effect of 3D printing on patents and how easy it is for people to create duplicate parts, particularly spare parts, particularly fairly basic parts for things, it can be a major problem. And a good example of this, moving to a different technology but with a very similar application, is the rollout of broadband internet. Now, broadband internet has been phenomenal in terms of the way it's changed our lives. It's changed the way that we can communicate. It's changed the way that we access information. It's changed the way that we can work. And let's be frank, I don't think any of us could have got through the last year in the way that we have without the innovation of broadband internet. However, when it was first starting to roll out, it did have a major impact on the media industry. And we had some examples early on, companies like Napster that were enabling peer-to-peer sharing, and from anywhere in the world you could access a music file or a movie file on someone else's PC over the internet, and you could access it in relatively good speeds because we now had the rollout of broadband. And this enabled a huge amount more piracy. And it didn't enable it because there was suddenly a huge amount more criminals out there willing to do it. It enabled it because it was now in everybody's home. It was easy for everybody to do it. It was accessible. And the lines were blurred. It was difficult to understand in the early days what was allowed and what wasn't allowed in terms of putting files as available files on the internet. And this had a massive knock-on effect on the media industry. So copyright protection was the mechanism that they used to protect their intellectual property, to protect their asset, their spare part, which is obviously it's not quite the same, but that was the method they used, copyright protection. And that copyright protection was rendered practically useless with the rollout of broadband internet. And we can see the impact it's had on the industry. 57% devaluation of the industry. Only 23% of music that we listen to now is owned by the person that's listening to it. Chances are they're streaming it now using services such as YouTube, like we're using today, or services such as Spotify. And the same goes for movies and TV as well. We saw in the video the shift to subscription in terms of things like Netflix. And the reason that these things have become popular is because this is the way that the industry reacted to try and resolve a problem with their copyright protection. And they tried a few things. There were some big court cases. Let's throw the book at people like Napster and try and make it, try and deter people from doing these things. Then they tried some heavy encryption, so embedding encryption into media files, and only certain approved players could actually play the file. But ultimately that was difficult for the end user. And the reality is, the way that they could finally beat this was to make it as simple as possible for people to do it in the legal correct way, which is where streaming services came into their own. And that's where actually broadband internet started to become the way that you could resolve the problem that it created in the first place. So if we quickly look back to our 3D printing scenario, this is one of our concerns that led to this digital transformation in physical security. So we've already addressed the why in terms of the risk and what's going on with the customer today. They've got a challenge. The customer has a challenge, and that's, what do I do when I lose my mechanical keys? That's a major problem for me. Look at the costs that we incur from that Wembley Stadium scenario, or from those prison keys scenario. So that's the immediate, okay, that's going on, and that's a customer message, and we like to listen to our customers through voice of the customer activities. Then there's a bit of forward thinking. You've got to try and, again, as a product manager, As an innovator, that's something you've got to do. You've got to try and look to the future and predict the impacts of certain trends and certain technologies in the market, and what they're going to have on your product. And the reality is, how far off are we from somebody taking a photo of a key from the other side of a room, surreptitiously, you don't even know they've done it, taking that photo home, running it through a piece of software that can create a 3D model of that key, and then plugging it into a 3D printer and creating a duplicate key. And these 3D printers are gradually going to get into every home. We saw early on in lockdown the number of people that had a 3D printer in their home that were helping in terms of printing parts for personal protective equipment. There is a 3D printer that you can purchase on eBay, which will 3D print all of the parts you need to build the 3D printer again, which is practically machines building machines. And if any of you that are watching have seen Terminator or The Matrix, I think we all know how that turns out. So these 3D printers are out there. They're becoming more common. They're becoming more accessible. 3D print shops will start opening up in high streets, and the reality is that it will get to that point where, for patent protection and spare parts, of which a key is considered a spare part, we will need new methods of controlling and securing that intellectual property, that security device. And that's another reason for introducing digital transformation, introducing electronics to something physical. By introducing those electronics, you make it impossible for that 3D printer to copy it, because there's something that it can't see, there's something that you can't model, and that's the electronic encryption that resides inside the head of the key. So those were the things that drove our development, and what we're here to talk about today is that specific digital transformation, that specific shift in the world of physical security. So we're talking about key-based physical security here: padlocks, furniture locks, door cylinders, areas that we have always traditionally locked using a mechanical key system for ease of installation, and because typically there's thousands of these locking points potentially that we need to secure, and we've looked at the challenges in terms of, okay, we've got these thousands of locking points. That's not going to go away. There's always going to be these locking points. They're always going to need something to secure them. But we've looked at the challenges. What happens when I lose a key? Well, now I've got to think about changing my locks, or I've got to incur a risk as a business. What happens with future technologies? How protected am I for the next 5 years, for the next 10 years? I have this patent on my key system. Is that necessarily enough in terms of the way that technology is driving forward? And so we're looking at how we apply digital technology to that environment and make a solution that works for the customer. And our solution is to combine the two. We never want to make massive leaps forward. Transformation, it doesn't really matter whether it's digital or whether it's another technological transformation or whether it's a very mechanical transformation. The reality is that transformation in ginormous leaps tends to be very difficult. It's difficult for people to accept it. The example in the video at the beginning, where we started to look at 3D printed engine parts, there was also some examples in there of robotics, and there was also some examples in there of driverless cars. Now, it's going to be a brave person that gets behind the wheel, so to speak, of the first driverless car and really gives it a proper test. But now imagine the first driverless plane, passenger plane, that everybody's going to get into. That takes a long time for that trust to build up. You can't click your fingers and say, okay, let's get on this 747. There isn't a pilot, by the way, it flies itself. There's going to be a major mistrust of that. And so it's a generational shift that's required there to accept this new innovation. It will take probably 20, 30, 40, 50 years. Even if the technology exists today, it will take that time for people to build up that trust and for it to become normal. At some stage, things do start to become normal. I think a good example as well of this is if we look to the past, is the very first time that somebody stuck a satellite dish on their house. Everybody else in the street probably looked at that satellite dish and said, what on earth is that? Why have you stuck that on the outside of your house? Let's be honest, they're not the most attractive devices you could imagine. And now Every house in the street's got a satellite dish on it, and it's completely normal, and you wouldn't think twice when you saw one, because it takes that time for it to become normal and become an accepted part of day-to-day life. So we didn't want to make a massive leap with this, and the important thing here is that still looks like a key, and that's really important to the end user. People know how to use a key. People also put an element of trust in a key, in a physical system where you physically have to turn the lock. You understand what it's doing and you know how to use it. So we wanted to combine the world of mechanical keying that is tried and tested and trusted with the world of electronics and the world of access control, so that we can bring in the flexibility to turn off a key if it goes missing, to bring in things like time schedules, because people need to work at different times of day. They only necessarily need access at different times of day as well. And then to bring in traceability. And traceability in data is becoming more and more and more and more and more important. In fact, what to do with that data is becoming the major question. We think about it, when we think of data in an access control system, we think about it in terms of the user, the customer that owns the system, and they can see, I can see when somebody's gone through a particular door. That might be useful information to me. I can see where somebody's accessed a particular asset. That might be useful information to me as well. But that information could be useful to other people. Imagine, for example, during the pandemic that we've experienced over the last 12 months, being able to look at some statistics on the number of times doors were used within the City of London in terms of commercial premises. Would that be useful information in terms of understanding the patterns and movements of people in terms of the lockdown? That data all exists, and how that data is used long term will definitely start to change, and it's becoming more and more valuable to organisations. They will have their data. That data is valuable to them because they may have trends that they need to understand in terms of usage of their building. Maybe I need to make sure I've got a green and sustainable environment, so I want to turn on certain lights or turn off certain lights, adjust the heating based on where somebody is using their access credential at a certain time, and that's valuable to them in terms of meeting their sustainability goals. But they could have a value in that data in terms of selling it to a third party to say, well, I can also tell you how people are using this building, how often people are going through certain doors. And when you start to tie that data in with lots of other data sets from around that area, and you can really start to build up a picture of what's going on in an environment, the customer's not only created data that's useful for them, they've created a value, and they've created something that they can sell on to a third party just from their users walking around with their credentials. So the world of data and what will happen with it is going to explode over the next 10 years, and it's a very important part of access control going into the future. Of course, we wanted something that's also going to be highly encrypted and highly secure. There's no use moving forward in terms of all of this flexibility and functionality if what you're really doing is moving away from security, because ultimately the reason the customer was buying into a technology in the first place is because they had a security challenge. For example, because they've recently lost a mechanical key in their system and they're looking to do an upgrade. There's no use selling them the world of functionality if the technology can be defeated with a paperclip in terms of physical security. So that's another reason why it's important to combine the two, to have the world of electronics with the physical locking devices that we know, the cylinders that we know, and the standards that exist around security of those. In some cases, so in the case of our Protect 2 click technology, it's a combination of a full mechanical key. So the key looks, the key part of the key, the shaft of the key looks like a mechanical key, operates like a mechanical key, is cut to a code, a unique code to the customer like a mechanical key, and can work in mechanical locks like a mechanical key, but then also has an electronic element overlaid on top to make it an electronic access control credential that creates the flexibility and delivers the audit trails and integrations and things as well. There's also completely electronic key based, where we don't have any mechanical differences on the key, but it still works like a key, looks like a key, and is used in the same physical form cylinders and padlocks Again, it's easy for people to understand and for people to use. And there are advantages to the two, where a customer's got potentially thousands of locking points. They may not be looking to achieve electronic access control on all of those thousands of locking points. Firstly, that's likely to be unachievable in terms of the cost of it. But secondly, you just simply don't need audit trails on every single type of door. Sometimes you just need the main entrance to know who's in an area at a given time. And so there can be a major cost benefit to having a combination of mechanical and electronic security products, all in one system, all used by one key. And then, of course, in terms of electronic cylinders, we can't forget that there are card-based RFID cylinder technologies out there as well. But for the purposes of this presentation, we're looking at the physical security space and the shift from mechanical keys to electronic keys. So once we've done that, we've applied some electronics to a well-known device. So we've got our innovation. We understand why we need to do it. We understand the requirements from the market, from the customer. We understand the trends, what's going on in the market over the years to come. We've decided to make that innovation, that leap, in a sensible, sustainable way. So we've combined a mechanical and an electronic device into a key, into something that's well known. It's not that massive leap forward like the driverless aeroplane. It's that small leap forward, potentially like a semi-autonomous vehicle. And we've now applied that electronics to it. It now means we're into the world of software. We're into the world of other devices. And what else can we do now that we've got that data and we've got that connectivity with the device? Well, one of the things we've been able to do using the latest Bluetooth Low Energy technology is actually change the way that we can get information to the key. So this is one of the challenges with access control, particularly in geographically dispersed installations. If we think of large-scale retail, where we've got stores all over the country, they've got basic mechanical locking potentially on main entrances and storerooms and store cupboards and things. Simple mechanical security on those, completely decentralized. So nothing linking all of them together because they've just been added over the years as an organization has grown. So being able to achieve flexible access control in that type of environment is very, very difficult. Conventional access control all needs to be networked together. That's got an expense and a cost to it that in terms of installation and in terms of hardware and infrastructure, and it's probably simply going to be unachievable. And so having the physical key-based system swap out a cylinder, no wiring, no networks, no software to go on site, can be the most achievable thing. But now we need a way of programming that lock or that key when we need to. And we don't want to run a network out to every single retail store in the country. That's just as expensive as putting in the conventional access control in the first place. So what do we do? Well, the answer to that comes in the form of the network that everybody's carrying around in their pocket. So the smartphone. By creating an app on the smartphone that can interface with the key, we enable people to update their keys from anywhere in the world. They can then update their key, which can update a lock from anywhere in the world. So with now zero infrastructure around the locking device, not even a power supply, not even a battery in the locking device itself, we can update it flexibly as the access requirements change within the organization. On top of that, we can deal with the final problem that we have with keys. So we've dealt with the lost or stolen key, major problem with keys. We've dealt with I know where the key's been. That's another problem with mechanical keys. You don't know where people are using them. We dealt with that because we've got an audit trail in the memory of the key and in the memory of the lock that's reported back on the software. The final problem we have is what happens when people lend their keys to somebody else? And this is something that happens a lot of the time. So we've got the audit trail, that's great, but it says that Fred was in the door and actually he'd lent his key to Bob and we don't know. And so the issue with lending keys to other people has always been a major challenge. And with this Bluetooth Low Energy, we've been able to deal with that as well, because we have this three-factor authentication at every lock. When you use your key in the lock, you've got to have the right mechanical cut on the key, potentially. You've got to have the right electronic valid access in that lock at that particular time. And then on top of that, your phone is going to ask you to prove who you are before the key will work. And to prove who you are, you enter your own individual PIN number, or you use your biometric credential if it's a phone that supports thumbprint or Face ID or something like that for verifying that activation. It's a local activation, so no infrastructure required. You don't even need a phone signal to be able to do this on the key. So you could be in the middle of nowhere, faced with a padlock, installed in the harshest environment you could imagine, and you've got three-factor authentication. You have to have the right mechanical cut, you've got to have the right electronic access, and then on top of that, you've got to prove who you are with your biometric credential. And you really can't get more secure than that in terms of the use of a key system with very, very simple installation. And let's not forget, for the installation of that padlock, it's exactly the same as its mechanical counterpart. Hang it on a hasp, job done. Then in the world of software, there's loads of things that we can start to do. So we've now got data, we're getting information back from the locks. We can turn keys on and off remotely in the field, anywhere in the world. We can start to create cause and effect. We can look at decision making automation. How do we make sure that the person's key is turned on just when they need it to be turned on? You know, perhaps we're looking at geolocation services around that device, that phone, or around a van, for example. If it goes into this particular area, then the key can work. If it's not in that particular area, then the key will never need to work. And ultimately, what we need to be working towards is a key is only doing what it's designed to do for the smallest fraction of its life. Probably something like 0.00001% of its life is a key actually doing what it's designed to do. And that's the few seconds each day that it's actually in a lock. The rest of the time that key is in your pocket, or it's on your dashboard, or it's in your glove box, or it's in your drawer at home, the rest of the time that key doesn't need access to anything. Now, if it's a mechanical key, it's got access to everything all the time. What we want to work towards is it's an electronic key that doesn't have access until something automatically enables it to have access. So we have that cause and effect. We have that decision automation within the system. And we can start to visualize that. So we have software that enables us to upload floor plans, 3D models of sites and buildings and areas, so that you can actually see that key system in operation. And locks are different colors based on the number of times a day that they're being used, so that you've got an easy visualization of how people are using your system. And then we want to start integrating that into all these different systems within an organization. And so we have an API first approach with product development, understanding that we're moving into an API economy. We're in that time where people really need things to come together. We've had the last few years, everybody's been talking about IoT, and there was an article probably 4 or 5 years ago now where they were saying IoT is already out of date. The Internet of Things actually needs to become the Internet of Thinking. It's all well and good having all of these connected devices. What we need to do is actually connect them to each other. So we've got millions and millions and millions of connected devices. You can have all of these things connected to the internet, a microwave and a fridge and a lock and an alarm system and a lighting system and telemetry system for machinery automation. But they all come with their own little bits of software. And actually what we need to do is get to a stage where all of these things interlink and work together to give a truly automated and efficient single system. And then out of all of those systems, we need to pull that information and create the visualization, have that single source of the truth that a customer is looking for in terms of their data. And there really is no end to what we can achieve in terms of that software side of things. So it brings a whole new world of benefit, where a customer previously, perhaps they just had a paper book and people signed a key in and out, and you really had no idea what they did with it thereafter. You really have no idea where most of the keys within your organization actually are at this particular point in time. So by making a small step, and that small step is applying some electronics to a key. Everything else stays the same. It's still a lock that goes in a door or on a gate in the same way that you've been used to. The key still works in the lock in the same way that it always did. So we've made a very small change. We've actually made a massive leap in terms of the benefit to the customer. And that's really true when you start to look at the return on investment. So if we look at a traditional mechanical system where we have a mechanical key system on day one, the value to the organization is its maximum. That's where you've just spent your money on the mechanical key system. All of the keys are in check, you know where they are, and you've designed the system around the needs of your business. 6 months later, well, the accountants have already started depreciating that capex expenditure, so you've already lost some of the value of your mechanical key system anyway. But also potentially you've lost one or two keys, and so from a security perspective you're slightly compromised. And maybe your business has changed, because let's be honest, no business is staying the same for very long these days. Maybe you've got a new team of people that need slightly different access to the last team of people, and your mechanical key system is very static. Doesn't matter how good our master keying department is, they can't predict the future, therefore they can't design you a system that's always going to change and meet the needs of your organisation. So your key system loses value very quickly over time. Now if we look at that same scenario with an electronic key system, now the upfront value is higher, absolutely. We've got an electronic device, it's got more to it, more componentry, we've got software and everything that comes alongside it. But in reality, the value of it 6 months later is arguably higher than the value of it when you purchased it. Because if you've lost keys, it doesn't matter, because you've removed them. They're no risk to the organisation. You've got now 6 months worth of data from all of your keys. So you've got a value in that data. And that data will have different values to different types of customers. Sometimes it will be, for example, we do a lot of work, and hopefully you'll stick around to watch one of our presenters, Sean, talking about the work that we do in medicine management. So for some customers, that data is about who's had access to a controlled substance, and making sure that traceability of those substances meets the requirements of the Home Office regulations. So data has different values to different people, and so arguably there's an increase in value there. And also you've been able to adapt the system to meet the organisation changes. So it's flexible and it's moved with the times, and therefore you haven't lost the value in terms of people having to carry more than one key. So the return on investment argument is really important with the shift to these electronic key systems. If we look at installation, it couldn't really be any simpler. The reality is, if we look at a conventional access control system, we've got a lot of cables. We've got door furniture. So here, for example, is a compliant access control door. If we look at the cost of that standard specification on a compliant access control door, this is a fire and emergency escape door. So we've got certain standards that we have to meet in the commercial environment around this door. It's got to have a lock case and a handle set to BS-EN 179 for emergency escape. So I've got certain hardware that I've got to have on the door. Now I've got to core drill the door. I need a door loop to get my cable back to my door access controller, and ultimately I need a power supply to power all of that as well. And I've got a fairly complicated installation, so roughly half a day to install that standard electric locking package. And we surveyed a number of installers up and down the country, and came out with a number, not based on our hardware, based on a typical access control door, and it was £1,200. We then look at that same door, same requirement, BS-EN 179. It's an emergency escape door. It's also a fire door, so we've got to have something that's got a valid fire test. If we reuse the existing mechanical lock case that chances are is already in the door, and a handle set, this is a DIN lock case. We haven't changed, therefore, the lock case and the handles, so we haven't compromised the harmonised standards, the package on the door that meets EN 179. All we're doing is changing the cylinder, which is not harmonised, and therefore this is still a compliant door, and it's £400, third of the price, and a 5-minute installation. Even if we had to change the hardware, we've got to change it to a mechanical lock case to 179 and a lever handle set to 179. Even then, probably less than 50% of the cost of a traditional access control door. So some major advantages in terms of the cost of it. Now obviously versus an access control door, keys are more expensive than cards. So we've got to make a decision about credential volumes and turnovers within our organisation. Is a key-based system the right way to go, or is a card-based system the right way to go in terms of what my customer needs? If the locking points are vast and the credential volumes are modest, or the turnover of those credentials is fairly controlled. So if we go back to maybe that retail example, we've got locking points all over the country. That's the main challenge. And then we've got one or two keys, credentials per store, fairly fixed in terms of the control of those keys, and it's a mechanical key system that they're using now and have been for years. Then actually the most cost-effective solution for that customer is probably to go for an electronic key system. If we think of a hotel where the turnover of credentials is massive, the doors, number of doors is fairly high as well, but they're all in one location. And fairly easy to do with wireless access control products. And there's another webinar you can watch later on today to show you some of the changes that we're seeing over the course of the next year in our wireless access control portfolio. That hotel environment, people are going home with their hotel cards in their pockets, accidentally forgetting to hand them in when they check out. That'd be a bit of an expensive exercise if we were doing it with keys. So there are obviously the right solutions for the right markets. In terms of a system, what makes up a system, we've got various different ways we can manage a system. Probably the most popular is our remote system, which is where we have a web manager, cloud-based infrastructure. So from a customer perspective, the IT infrastructure is all taken away and is hosted and managed and patched and supported and developed by ASSA ABLOY. And then you have a simple browser interface to access your key system, and you can see all of your keys. You have a programming key for logging into the system, and also for making programming changes to the cylinders if you need to, although in a well-designed system you should never ever need to go and visit a cylinder to reprogram it. And then you have your user keys and locks, and then your keys are updated either through a network of programming devices that connect out to the software in the cloud, or through the smartphone for that ultimate flexibility. So from a customer perspective, it's a key and a lock, and nothing really changes. And it is important, I'll retouch on this, that changing the cylinder on an emergency or panic escape designated door does not void the compliance of that door, because the cylinder is not part of those harmonised standards for escape. So it is a really easy way to upgrade the security and the flexibility of a door, but maintain the compliance, which is very important. Life safety ultimately is the most important feature of that door. Then lots of other benefits in terms of aesthetics. Changing a cylinder, really simple. It's also easy to hide. It just looks like a normal cylinder, so hiding it behind an ornate escutcheon, for example, makes it an ideal solution for that heritage market. And we've got a number of customers that are using this in stately homes, even a castle, where you can imagine installing access control in a castle, drilling through half-meter thick concrete walls and things is a bit of a challenge. Then obviously the simple change of a cylinder into a heavy door is the easiest installation they could achieve. And obviously you can have it in any colour you like in terms of finish as well. In terms of environmental impact and I guess our triple bottom line, the people, profit and planet, that is more and more important to people these days, and will be a massive topic post-pandemic, I think, as well, in terms of maintaining the sustainability that we've been able to achieve during the course of the last year. Every organisation has a responsibility, whether they're a small or medium-sized business or whether they're a large enterprise. In fact, it's often the small and medium-sized businesses that need more assistance with this than it is the large enterprises that have got resources around it. And moving to an electronic key system can give you that sustainability angle as well. One of the big things that we've seen in organisations is the amount of transportation waste, where people are going to collect keys, because you can't afford to give everybody their own mechanical key. that would be a big risk, because if that mechanical key goes missing, there's nothing you can do about it other than change all your locks. And so that's a big problem. And so one of the things that we have done is reduce transportation waste by giving everybody a key, and that key just turns itself on when you need it to. And so therefore there is no risk to everybody having their own key. In terms of installation, we've got basically every locking device we can do mechanically, we can do electronically. So a wealth of different markets that this type of technology is suitable for, from drugs covers, where we do a lot of work, to server racks, to the back of containers and shipping, and offshore oil in harsh environments, cash in transit, street furniture, and the built environment, of course, as well, where changing a cylinder in a door is the simplest installation that you could possibly do. In terms of performance specification, I'm actually going to skip past this slide because we're running a little bit close on time. But there is plenty of information around the physical hardware standards, the software and infrastructure standards, and the services around supporting that software, the organisations that we work with in terms of maintaining physical and electronic security, and of course the IT infrastructure security around providing a cloud-hosted solution. So it is absolutely worth getting your questions into the chat if you haven't done so already, or getting in contact afterwards if you have got any questions around that performance specification side of the product, making sure that it's a product that's fit for purpose in a high security application. One thing that is an important observation, something that can be actually found in the guidance on the control and use of key locks from CP&I, is that it's this statement here really: some commercial makers have put ease of use above absolute security. And this goes back to something we were saying much earlier on in the presentation. It's all well and good having all of this functionality. It's all well and good having this big shift to electronics. But if you compromise on the physical security of the product, and that was the reason the customer was buying into it in the first place, you can try and baffle them with functions and features, but ultimately you don't achieve what they set out to achieve, which is to re-secure their premises. So relying on just electronic features and functionality alone is not enough. We've got to have that physical security. The patent is still important, regardless of what happens with 3D printing. It is a massive element of control of keys within our market, and so are the physical standards that were on the previous slide. And as I say, you can get in contact with Abloy and ask the questions if you need to. So in terms of what comes next, we've moved to this world of electronic keys. What's beyond this? Again, if you listen to our presentation later on today on the future of wireless access control, there'll be a little bit more information on the solution that comes next. So we've had mechanical, we've moved to a world of electronic keys, and that's that first step. We don't want to make that quantum leap to something that will never be adopted and never meet the requirements of the market. It's too far, too quickly. But we've had this product in the marketplace for 10 years now. And innovation is something that we have to continue to do. And particularly in the world of the padlock, where Abloy has spent over 100 years as one of the leading manufacturers in the world of high security padlocks. Innovation calls for game-changing thinking. And this is just a teaser for you around the Abloy Beat solution, which is our latest addition to our digital portfolio. Works seamlessly alongside our electronic key systems, which also work seamlessly alongside our mechanical platforms. So customers that started their Abloy journey 20 years ago with a Protec key system, maybe upgraded to a click system when we launched the click technology 10 years ago in the remote form, can now move to a keyless Beat solution as part of their system. And they're still using their mechanical investment, they're still using their click investment, and now they've got their keyless investment. All in one system, all under one software, all working seamlessly side by side. And I guess that brings us to the close of the presentation with the important message that innovation and digital transformation is a journey. It's not something that we can just do because something seemed like it was a good idea. customers that, particularly Abloy customers that have been with us for a long time, can see that the world of digitalization is accelerating. Things are happening very, very quickly. The reality is, if we were going off and doing things in different directions all over the place without a strategy, it would become very difficult for customers to maintain their security system, to move with these technologies, because they'd be reinvesting in something every 6 months. The reality is, customers that are using our Click or Beat technologies can use them on top of mechanical solutions that have been in place for 20 years. So innovation is a journey, and it's important that we have a journey and a roadmap for our customer base. So thank you very much for listening. For those of you that are looking for CPD points, this is a core curriculum CPD. So if you are interested in getting a certificate following today's session, please send an email into marketing@abloy.co.uk asking for a certificate. We'll need your name and your email address, and we'll get a certificate sent out to you. Please have a good look around the stand. There's plenty of literature to download. There's lots of other live events going on today. And please do use the chat functionality as well. Make sure that my colleagues that are manning the chat rooms today are well tested. So I hope it's been an interesting presentation for you. I hope you enjoy the rest of today's showcase, and I hope to be speaking to you all very soon.